So where would I be at? What kind of grade would I be getting out of here if I got 50% on these and 100% attendance? Anybody have a calculator? What percentage are we at? Total is 650 points, right? So this over 650. Where would we be at? What grade would we be getting?
70%.
70%? So that's a what? Can you see on the grading scale where we're at? We're about a C+, right? So if you get 50% on everything except for attendance, and you're here all the time, then you should be able to pass the class. Okay? Again, I think everybody should be able to get 90% on your homeworks. And now the tests are difficult, but you want to aim for more towards 60, 70%. Okay? See if you can get yourself up there. Another thing about the exams, well, we can see on here when the exams are. Can somebody tell me when the first exam is? September 27th. What days does it cover? Or sorry, what chapters does it cover? What chapters does it cover? Chapter 1 through 3. All right. And the second exam is on October 28th. Is that true? And its chapters are 1 through 6. So the fact that it's covering chapters 1 through 3 again indicates that it's what? What do we call that? Important. Well, it's cumulative, right? It's cumulative. So that you're going to be tested on chapters 1 through 3 essentially once, twice, and then the final again, right? Now that's good because if you score, for example, exam 1, I score 35%. That was a horrible exam. Oh, I didn't know. Why does it have to be that hard? I didn't get it. Blah, blah, blah. Whatever. Or maybe you broke up with your significant other or whatever. 35%. It's horrible. Or maybe you didn't take it. I had to go to my brother's wedding. Sorry, didn't take it. Right? If you do better on exam 2, which is chapters 1 through 6, so this is chapters 1 through 3, right? You do better on exam 2, it should be an indicator that you have grasped chapters 1 through 3, right? Sorry, did I say 1 through 3 like 1 through 6? Right? Because you were retested on it and now you did good on it. So you'll change the score. So instead of whatever you had, you'll get this score if you've improved on it, right? And the same thing with the final. If you take the final and you get 50%, this is chapters 1 through 10, so we can change these all to 50%. So essentially, you're taking the same exam 3 times, trying to improve on your score. And to me, I don't care if you take these. This is the one that's going to tell me. But if you miss out on taking these exams, you'll miss out on the opportunity of recognizing the level of commitment, the level of rigor that you need to have to do well on exams, right? So they're really just opportunities to prepare you for that exam. Okay, so we've gone over attendance, homework, exams. What else do we got? I think that's about all. There's some very interesting information down here. Honor code, discrimination, sexual harassment, sexual misconduct, student academic grievance policies. All right. If you have any concerns, you can talk to me about absolutely anything, or you can review this, and it will give you other email addresses to go to with concerns. Okay? Let's see. We talked about the book you need. Is there any other questions that anybody might have? This is going to be a tough class. We're all tired, right? 2 o'clock. I told you that you're going to be working in kind of groups, right? And right now, you should try to make a commitment to each other, whatever groups it is. It doesn't need to be 2 people, it can be 3 or 4 people. You should decide kind of collectively what grade you want to get. Are you interested in a C, C+, or are you an A kind of person, right? And then commit to it. Commit to it. Commit to showing up. If you don't show up, you don't have an opportunity to learn with your group that day, it becomes difficult. It becomes difficult and haphazard, right? You just can't tell what's going on. So making that commitment is a big deal. This is a chemistry class, but to me it's much more than that, because there's a relationship between seeking for truth, absolutely anywhere, seeking for truth, and your long-term happiness. Your long-term happiness. Seeking for truth, trying to live that truth, and your long-term happiness. Now, the farther distance away you are from the truth, the sooner your happiness will run out. Right? So if you just kind of, I know that this isn't real, but I sell it to people and they love it, right? Gradually, it'll run out. It'll run out. Your ability to find happiness in dishonesty will never last. Never last. What if you don't know it's dishonesty? What if you're just trying to do what you think is right? It doesn't matter. It doesn't matter. Unfortunately, it doesn't matter. It doesn't matter how much I believe that if you drink a ton of water, you'll be cured from cancer. It just doesn't matter. I can't believe enough to make it happen. Right? You have to engage with the truth of nature to be able to solve the problems that are real. Okay? So to me, and not just to me, religion is just seeking for truth. And to that extent, this class will allow you to engage and recognize the truths of the world around you, the nature around you. And you cannot skirt nature. You can't trick it. Right? So you will not be able to find happiness in living dishonesty or untruthfulness, even if you don't know you're living dishonestly or untruthful for an extended amount of time. It'll always get you. So that's the power that a class like this gives you, because the laws of nature don't change. The laws of nature don't change. Do they change in the eternities? I kind of don't think so. I don't think so. I don't think that there's any magic. Heavenly Father, is he magic? Did Jesus turn water to wine through magic? It's just some law of nature that he knows that he follows. And as we become more understanding of them, we increase our capability to manipulate the world around us. Not in a bad way, but in a way that improves lives, spreads the gospel, does the things that we want. All right. So, yeah. I don't want to talk about myself. Let's just talk about chemistry. So, let's hand out these slides here. Are there any other questions at all? Let's hand out these slides. Just there. And let's talk about what's science? How does science differ from something like democracy, philosophy, or religion? Science has a pattern. If you do something in a scientific way, then whenever you repeat it, you should always get exactly the same results. Right? That's a general definition of something that is scientific. So, for example, if I plant a seed and plant grows, right? Next time I plant a seed, exactly the same time every year, I should get exactly the same result. But what do you think? You think you're going to get the same result when you plant two seeds a year apart from each other? You might get a plant, but there's a chance that it will grow, right? So then you can say, that's not really science. There's an art to it. There's, I'm not very good at planting plants. I try to grow a lot of stuff here, and I can't get it to grow very good. So there's more than just the science aspect. There's an art to it, right? And that's fine. You can't say something is completely scientific. There's always a little bit of an art to it, or something using magic, which is basically saying an ability to perform the experiment. But science follows a pattern. The pattern is you look, you observe, you collect some data, you make a decision, make a hypothesis of some sort, and then you perform the experiment, and then you look and see what happened, and you start over. Right? Observe, make some conclusions, perform an experiment, make new observations, new conclusions, and change your experiment, and keep going in a cyclic nature. Right? The scientific method. And from that, we've gathered models. Models. Now, this is the model of an atom, right? Or this is a model that we're probably familiar with. Does this look foreign to anybody? What do we got in the middle here? Do we know what these are? What's the stuff in the middle there? Protons and neutrons. And the stuff around the outside? Electrons. All right, we'll get into that a little more. But in general, this is a model of the atom that you can see on the side of some baby jar, or, whatever. We see this sort of thing all the time. But it's a model. It's a model. It's not the truth, but it's the way that we interact with the truth that serves us very well. Okay? Let's see. Is there a little video here that wants to run?
You're watching the Science Now Daily Podcast.
I'm going to try to plug it in real quick. Hopefully it's not terribly loud. Whoop.
The Science Now Daily Podcast.
All right. So, why did they make that? What were they doing? Why did they make that video?
I was trying to prove that stuff your representation had any supposed to be able to do that.
Okay. All right. So it wasn't as much about the atom as it was about what? Scale.
Like the presentation of it.
Our model, right? How we think about it, our version of what it is. And it's dangerous to get stuck in the model so much that you can't figure out what's actually happening because you think, oh, this is how it should behave. Right? So, it's a model that serves us well, but it's not real. Okay? A lot of things are like that. So after you collect models and perform experiments over and over and get the same results, you come up with a theory, which is more general. Don't get hung up on the word theory. Some people say, well, it's just a theory, it's not really true. That doesn't matter. You know, don't get hung up on that. Some people use it as a word to mean it's only a theory, so it's not very true. And some people say, this is a scientific theory. It's really, really important, right? It's not. Scientific law, on the other hand, usually has a formula associated with it, right? A mathematical formula. It doesn't have all the variables. I don't see world peace in there, right? But it has a handful of variables, and changing those variables will give you exact values every time, right? So that's a scientific law, an equation associated with it. And it can be very strong. So. Okay. So, why does chemistry influence so many different things? It's because that's the level that we can manipulate and make significant changes, right? We can't shift around atoms very well, but we can make and change what we call molecules. Molecules. Now, an atom is a cluster of protons and neutrons in the nucleus surrounded by electrons, right? That's an atom. But a molecule is a cluster of, let me get a pen here, a cluster or a combination of atoms in some way, molecules. So we say a molecule of water. It has 2 hydrogens with 1 oxygen, right? You guys have seen this. Where did you guys learn that? Anybody know? It's just a part of it, isn't it? Nobody knows where they learned it. How about this? I think I learned these from cartoons when I was a kid. I don't know. You just learn this sort of stuff. But this is what we call a chemical formula. Right? A chemical formula. And all it's showing us is that there's 2 of what? 2 oxygens or 2 hydrogens? 2 hydrogens, 1 oxygen. All right? And so they come together to form what we call a molecule. Okay? If I have a container of water here, here's my container of water, I can say that this is a pure substance, it's pure water, if all of the molecules, all the atoms, sorry, are organized in the same way. They're all forming the same thing. Now, there's always a lot of talk about pure water, right? You can't drink pure water. It would ruin your kidneys. It would pull all the salt out of you. You'd probably die, right? So when somebody says, try this, it's pure water, are they trying to kill you? What are they really saying? Who knows, right? But it sells water, so they say it, right? Pure water. We'll have other conversations about that in the future. But if something is pure, that means that all of the molecules are organized in the same way. So you can have lots of things that are pure, right? Aspirin can be pure. All the molecules there are the same combination of atoms. Right? Now, elements. This is our periodic table. It shows us the different elements or the different kinds of atoms that exist. And that's it. It's just like Legos, right? But you don't get infinite different kinds of Legos. You just get like 116, and in reality it's really just like 70. Because a lot of them up there are made in the lab and they don't last very long. But that's it. Those are all the elements we have. Combining them together can form different kinds of molecules, or another way to say it is different kinds of compounds. All right, so we got a little beginning here, right? We started learning a little bit. Who feels like they already knew what we talked about today? Raise your hand. No? Who here is going to take Chem 105? Did I already ask you that? Who's going to take Chem 105? Thinks they want to take Chem 105. All right. So everybody else, what are you guys taking, or what you doing? It's just to fill a different requirement? Awesome. All right, so what are you going to do before Friday? Take that quiz. Do your homework, and then take that quiz. Okay, excellent. We'll see you then.